Okay, I want to play a little game with you before we start the actual lesson. Um, level 1 is pretty easy, but at least it kind of set the tone. So I'm just going to do one problem for level 1, and then I'm going to do another problem for level 2, and then I will ask you to do level 3, which is the more challenging one. Okay, so the objective for this game is really simple. All I'm asking you is to either you decide what to put into this machine, or you let the computer decide. Typically, you want to decide, okay, because you have control over the numbers that you want to input into this. And the good rule of thumb is choose something that's small enough for you to calculate, and choose something that's consecutive. You don't want to input 1 and all of a sudden jump to like 1,000. Okay, that's not consecutive. We talked about consecutive numbers before. So if you choose 1, and the next number could be 0 or 2. If you choose 2, you want to choose 1 or 3. You kind of see the deal with consecutive. So let's start with you decide. So once you input a number, so let's input 1. What do you want to put in? 1. So if I input a 1 into this machine will take the 1, processes it, and it spits back out 2. Okay. Right now you don't know what this machine really, what it was doing to your number. You don't know yet, and you're trying to guess what it's really doing inside this box right here. You want to open it up and make it transparent, but it's not transparent yet, so you want to take a look. Let's try another input. What do you want? Let's try 2. So it takes a 2, and then it processes it, and it gives you back a 4. Now you probably have a better idea. Can you tell me what is this machine doing to your number? It's multiplying by 2. So basically, what your number, whatever the input is that you give to the machine, it takes it, times it by 2 to give out the output, which is y, right? Does it work for 2? 2 times 2 is 4, so it's good. So then this is how you're going to write it. I would say y, which is the output, equals to the input times 2. So the input times 2. Is that clear? Do you see that part? Makes sense, right? Whatever the output is, it's going to be the input times by the input times 2. So if I say go, it validates, yes, you got it right. So that's your objective. Let's move on to level 2. Here's level 2. What do you want? What number? 3. Let's input a 3. It processes the 3, and it gives you back a 10. Okay, next one. What do you want? A 2. Okay, so you are going to put a 2. Can you predict what will happen? Not yet, right? Okay, it's not quite clear yet. Let's just go ahead and process that, and it will give you back an 8. So, what do you think just happened? So you got to count up 2 to 3 instead of going back 2 to 3, 2. So from 2 to 3, it also increased the output by what? By 2. So that means if you input a 4 in, what do you think your output's going to be?
12.
Think.
12.
8, 10. And so you input 4, you expect it to be 12. If you input 5, you expect it to be 14. A 6 can give you a 16. So you see the general pattern of this. What do you think this machine is doing to your number? It has to work for every single one, because if I throw it in input, it will process and give you back the correct response, the correct output. Yes? Oh, notice what she said. This machine will take your input, multiplied by 2, and then what? Add 4. Let's test it to see if it's going to work. 3 times 2 is 6. 6 plus 4 is 10. 2 times 2 is 4. 4 plus 4 is 8. 4 times 2 is 8. 8 plus 4 is 12. Oh, it works. So guess what? That is the definition of your machine. This machine will take in your input, times it by 2, plus 4. Where do you think the 2 comes from? Let me show you a trick so that next time when you do it, you will know exactly how to get your 2. Watch. Don't you notice that every time you do a comparison, this is why I asked you to do consecutive, right? From 2 to 3, don't you have to add 2? From 4 to 5, won't you have to add 2? From 5 to 6, don't you also have to add 2 to get 14 and 16? Everywhere, it is the same exact value of 2. This is what we call the common difference. Okay? And from that common difference, that is where you get your coefficient. That 2 is the actual 2 over here. So whatever the common difference is, that is your multiple factor. Okay? And then once you have it set, you can adjust it by either adding something or subtracting something to adjust it to your desired output. Okay. Okay. Now let's try another one right here. Okay. Take a look at this one. Let's do level 3 and see if you can actually figure it out. Here's level 3. What do you want your input to be?
10.
Okay, why is it that I don't recommend big numbers right away?
Because we're just starting out.
Make it easy for you to start to calculate. I would start with what? 0. Thank you. You don't hear from me, but yeah. You want to definitely start with 0. Watch what happened. If you input to a 0, it gives you a 23. Fine. What do you think the next one's going to be? 1. Okay. Now let's go back and validate this. What just happened? From if you input a 0, it gives you 23. You input a 1, it gives you 28. What is the common difference of the output? 5. It's going up or down? So it's positive 5. So 5 times something, right? And you have to adjust a little bit. How do you adjust it? The input? How do you adjust it to so that it will work for, if you input a 0, what is it? Thank you very much. I hope now you know why I asked you to choose 23. I mean 0. Because when you choose 0, that adjustment is right there. It's automatically there. Okay, what can happen? 5 times 1 is? Plus 23? There, it works. See that? So without having to do much calculation, you can actually figure out the equation right away. Let's try one more, okay? Let's see if you can actually, by the way, don't yell the answer, just tell me what it is. Raise your hand. What do you want to start with? You didn't take my 0, thank you, for those who actually pay attention. 0. Give you negative 52, okay? What do you think the next one's going to be? 1. So, if you input a 1, it's going to give you negative 51. What is my common difference? How do I write this? Y equals to what?
0 minus 52.
Write the entire equation for, you're not plugging it in yet. I want a generic form. What does it do to the input? Whatever input you put into your function, your machine, it's going to do something to it. What does it do first? So whatever you, okay, you tell me that whatever I put into there, I'm going to minus 52. What does it do? So how do you write this as a function? Y equal what? X minus 52, you said. Okay, let's see if that's going to work, okay? So you're saying this is your function. So if I take a 0 and put into X, 0 minus 52 is? Good. If I take 1 and put it here, 1 minus 52? Oh, it does work. There it is. See it? And why do you think it's X? Because guess what? The common difference here is a 1. Look at that. Isn't that a 1 right here? It is. Okay. Try one more. What do you want to use as your input? Thank you. 0. Alright, you put in a 0, it'll give you back a 65. What do you want your next value to be? 1. So I put in a 1, it's going to give me back a 73. So what just happened? So it goes by 8. So how do you define your function? Equals what? 8? Okay. Thank you very much. Do you see a pattern or no? Do you see a pattern yet? Notice that the common difference between your output will determine your coefficient in front of the letter X, which is your input, right? And whatever you get back as your 0 from 0 input, that is your adjustment value. Okay, so that indeed will give you the correct answers. Okay, questions so far on what we're doing? So symbolically, this is what it looks like if I'm asking you to evaluate a function, that means I require you to ask you to give it an input, process it, and get back an output by doing some mathematical calculations to get back an output. Okay? Here, you don't have to do it because the machine's doing it for you. But when you are doing it at home, you are the machine. That's what you're doing. You are the machine. I give you the input. You process it yourself, and then you give me the output. Okay? So what does it look like when I put this back here as a function notation? Let's talk about that for a minute. So for this particular lessons right here, I want to talk about how would you represent a linear function. Oh man, I can't spell today, guys. Representing. Okay, and more specifically, function notation. Okay, this is what we want to focus on today, a function notation. What is it really? I don't want to scare you away, but function notation is nothing more than it's just a format. It's like, hey, I want you to guys write a persuasive essay. And then you know that there's a certain format for a persuasive essay. It's not just an essay, but if I ask you to write a persuasive, there has to be a format for it. If I want you to do an expository writing, whatever, then you do that too, right? So in mathematics, it is the same way. When I ask you to write a function notation, there is a specific format that you have to adhere to. So in the past, we know how to write a general equation. For instance, if I ask you to write this, y equals 2x, what it means is, whatever x is, I process it, and then it'll give me back the y, right? So which variable here is considered to be your input variable? X. And your output is going to be y. So can I translate this and write it like this? So this same equation, I can write it like this. The output is 2 times the input. It's the same thing as above. Do you agree with me? So I'm not doing anything different. I'm just telling you that we have different ways to write it. So instead of writing it y equal to 2x or output equal to 2 times the input, I write it using what we call the function notation. And depending on what I specify, if I tell you that, hey, I want you to use letter F, I want you to use letter Z, letter K for your function, then you have to use the specific letter. So let's say I want you to use letter K for this function. Then this is how you write it. Same exact equation, this is how you write it. Function K, think of it as a machine. Machine K, I'm naming this machine, it's going to take in an input. Well, in this case, the input is X, right? It processes the input by timing it by 2, and that's it. This is called a function notation. Is it really that much different from the original one? One tiny bit. Look at it. That's the only thing that's different. So if I ask you to convert it back to a function notation, that's all I'm asking you to do. Okay? This is not K times X. No, we don't read it like that. We read it as K of X. K of X. Function K of X. Okay? That's how you call it. Function K of X. What does the function K of X do? It will take your input, whatever you give it, times it by 2, and it spit out on an output. Just like here. And if you really want to understand it better, just go ahead and replace the appropriate letter with the word input and output to explain it better for you. Because sometimes you see this letter X, I'm like, I don't know what that is. Can you just replace it? No. So that means, oh, right now I know I have to take 2 times the input, and what do I get back? That's my output. That's all. Okay? So this is a very basic structure of a function notation. Let me tell you, let's try, yes, go ahead. Yes. Okay, so if I give you another one, ask you to rewrite it, let me show you this. Let's say I have this. Let's say that, all right? Which one here is my input? Which one's my output? Yes. And T is input. So if you want to rewrite it to help you understand it better, I write it like this. Output equals to 3 times the input, right? Minus the 4. Is that true? How do I rewrite this as a function notation? Name this using letter F. How do you name this? How do you rewrite this as a function notation using letter F as a name for the machine? What do you do? How do you start? Yes. F. What's the input? What letter is the input in this case?
T.
T. Good. Equals?
3 minus 18 minus 4.
That's it. That's the only thing that's different. The left-hand side. The right-hand side exactly as above. You see it? That's it. Okay, so now, if I ask you this, okay, guys, I want to throw you. Yes, go ahead.
How did you get that?
I just randomly ask you, hey, name this machine F. I give you a name. If I ask you to name this machine M, then you use the letter M instead. Understand? This is what I give you. So now look, I ask you to go ahead and evaluate this function using the input of 4. What does it mean? It means that your function F now, based on its definition, will take in the input of 4. What does it do to the input?
Multiply it by 3 minus
It multiplies by 3 and minus 4. See it? So then you just have to write it out. Okay, whatever the input is, I multiply by 3, right? And I subtract 4. So and then I evaluate my function, and what will I get? 12 minus 4, which is 8. And so that's my output. I'm done. Yes?
You just get the farthest number. From
What do you mean?
like, you know how you got 4?
This is the definition of your function.
So we just have to write out that.
So you want to convert this into a function notation, and then I'll throw you a couple of inputs, and then you act as a machine and process the input and give me back an output. Yes?
Why is it 4?
Oh, why is this for?
Yeah.
I just randomly give you one.
Um,
This, remember when we decide on a machine? You decide what to give, I decide this time. I say, hey, do this for me, 4. You are the machine this time. You're waiting for my input. That's what's happening. So we are doing the reversal role in a sense. You were the one who's giving out the input, right? And then the machine will do it for you. Now you act as a machine. I give you the input and you process and give me back the output. Okay, let's try one more. What if I said, okay guys, I want you to process -2 for me. What will happen to the -2 as it run through your machine? What happened to -2?
3 times -2 minus
So
times 3.
based on the
4.
definition, we'll do what?
Minus 3.
Okay,
I mean, times 3.
times it by 3. Good.
Plus-
Okay.
I mean, minus 4.
Very good. See that? Because the machine tells me that I'm going to times it by 3 and then minus 4. So when I run it through, it's going to be -6 minus 4, which is -10. That's my output. And that's what you're going to give me. Any questions so far? Questions on that? One more input here, so you can actually process it. What if your machine now, I'm throwing a really weird input. I said, hey guys, I want you to go ahead and process this input for me. What's the input this time?
2A.
Good, 2A. So whatever I throw at you, you take it and process it, and try to process it anyway to the best of your ability. What does it do to the 2A?
multiply it by minus 4.
Times it by 3. So I'm going to go ahead and write it out. Okay, whatever my input is, remember, this is your input. And I times it by 3, and then once I'm done timing it by 3, I subtract 4. So let's process what I can. What's 2A times 3?
6A.
6A, and then minus 4. But notice that I can't combine like terms, so I just leave it like that, and that's my output. That's it. Questions so far? Remember that the machine can change. If I give you a different machine with a different definition, then you have to apply the machine. Okay, so for instance, if I, for example, introduce to you like 2 different set of machines working all at once. Here's the A machine taking in an input, and what it does is it's going to take the input and divide it by half. That's the first machine. Here's another machine taking in another input. Let's take in Z, for example. And what it does to Z is it's going to take it and square it. Okay, 2 different machines. You see that, right? Machine A, machine B. It has different ways of calculating your numbers. And so I ask you this question. Okay, guys, if I want to ask you to process this for me, what is machine A is going to give you back?
9.
Very good, 9. Raise your hand if you don't understand why it's 9. We all, Jamie, you don't know why it's 9?
Oh,
Because machine A is what? What is it doing to the input?
dividing
It's divided by half, that's why. Okay, makes sense, right? Here's machine B. I want to go ahead and ask you to process, let me see, 7. What do you think it's going to give you?
49.
Very good, it is, because whatever the input is, I square. So it becomes 49. Raise your hand if you're like clueless right now. Margaret?
I'm not just.
Okay, good. Okay, here's the next step. I want you to go ahead and take machine A, process 22, and once I'm done with that, I'm going to go ahead and times that by 3, add it to machine B, and then I want you to process -5. Okay, see if you can actually do that for me. So, one step at a time. Look at machine A. What is it taking in? Okay, what will it give you back? 11, and then what do you do with that? Which is? Very good. Okay, what is machine B doing? Okay, and what does it do with -5? Square it, which becomes? Okay, let me ask you this question. Is it positive 25 or negative 25?
Positive.
Good, because a -5 times a -5 is positive, so it's 25, right? And then I asked you to add. What is my answer now? 60? 58, right? 58. And this answer is made up by combining two machines together to do it. Okay? But this is the case. Any question at all? Is this like too difficult?
Can you just stop using C as the end of y and C as a variable?
It doesn't matter. I mean, whatever I specify, you just have to do it. Okay. Yes, Margaret?
Doesn't matter what variable you use.
Usually I would specify which one you use. Okay? I would just give you a machine, I'll give you the input, and you can process it. That's your job. Okay, we good? Okay. Alright, so if you have no further questions, let's stop this right here for a minute.